that it can sit where you want it to sit and do it properly. That will cost something like £100,000 in the UK. You need to put it in a semi-clean room at least, if not a clean room, and those will cost maybe about £100,000 for the size of the machine. Now, even if you say that your liquid nitrogen bill is going to be £50,000 a year for one of these machines, and you're running it for 10 years, that's another $500,000. You can see there that I put that down. To grow, you need the source materials, you need high purity elements like gallium and arsenic, indium, phosphorus, you need electricity, you need gases, you need deionized water, you these Knudsen cells, you need crucibles, you need valves, you need to do minor repairs, consumables. You don't forget you need to also have staff. There's no point having a very complicated piece of kit and then having no staff to operate it. So you probably need a postdoctoral researcher and a technician. And so by the time you add all this up, you come to something like, it comes to something like £300,000 per annum. Now if I convert that to US dollars, and I look at how many minutes there are in a year, the cost of running this MBE machine is about $1 a minute. It's $1 a minute for every minute, for every hour, every day in a year. Morning, noon, and night, and at weekends. So this is why it is not a good idea to get into buying very complicated pieces of kit like this, unless you are very confident that you have enough money to keep it operational over that 10-year period. Okay? So it makes much more sense to put it in one or two places and then invite other people to come and use it so that there's a very high utilization. It makes much more sense than to have expensive pieces of kit sitting around and then not being used for large fractions of the day. Even at Sheffield, we tend not to use these machines at weekends. So, if we wanted to, we could get much more throughput by just starting to have a weekend shift and making sure that we employ people to operate it. Because most of the infrastructure is already there, it'll be easier for us to increase our capacity that way than to give more of these expensive pieces of kit to other universities. So, I'm not going to tell you how we manage it because that's for a sort of another talk really. But the future, I've said to you that we have funding till next year. The future looks good. We are at this precise moment supporting 35 grants in 19 UK universities, and the total worth of all the grants with us and those universities is something like £24 million. Now, the question is, how much longer would you want to run a facility like this? Well, the future is unclear. We used to have silicon facilities like Sheffield, at Edinburgh and Southampton until recently, and those facilities were wound down. The reason is that we decided that silicon is now a commodity. You can easily go to Korea, Taiwan, Japan, China, America, and there are fabs that will do whatever you want. You just do the design using a computer, you send it off, they will then produce these and ship it to you. It's all in the hands of the industry now. Universities will not try and set up a silicon fab line in a university. That is still not the case for 3.5s. 3.5s has matured, but there are still lots of interesting things that you can do with 3.5s that industry isn't fully running with. An example of it would be, say, the growth of 3.5s on silicon, integrating lasers, detectors on a silicon platform, magnetic semiconductors where you are integrating magnetic properties with optical properties. That's something that's being looked at. And looking at novel material combinations, putting in things like antimony, bismuth, which will open up new devices and new applications. The main advantages of having a central facility model is to say that you can actually get devices and wafers very, very quickly because you are going and talking to a group of experts. You have an idea, you can pick up a phone, you need to have a grant funded by the government, but once you have that, within literally a few weeks, you can start to obtain wafers to your own personal design specification. So this allows you to do very quick pump priming projects or feasibility studies without losing the momentum. So, and in topical research, the time scale is very, very short. If you don't do something within 3 months or 6 months, there's some Korean team or Japanese team has beaten you to it and they publish the results. So speed is of the essence. And you've got to have the core expertise in this one place within the country. It's no good having one person in this university and another person in another university. The opportunity for them to meet and interact is not that high. So by having a large research facility that is concentrated in one place, you find that you have a pool of expert knowledge to help not just academia, but to help industry. And this, don't forget, is not just benefiting the university it's at, it's benefiting every university in the country. It generates publications because you have very good equipment, you've got very good staff. We typically publish over 100 high impact factor journal publications per annum just from the facility staff. And of course, there are lots of spin-off benefits as well. There's a lot of training, there's a lot of manpower benefits. There are hundreds of successful PhDs, both internal and external, who benefited from having world-beating material and devices from these facilities. There are some problems such as who owns the intellectual property and such like, but we won't look at that at present. So if you look at what is going on in a country like Malaysia at the moment, the government is willing to invest in high technology. It sees that as the way forward. And there are a large number of universities, and seem to be increasing all the time, but many of them have actually inadequate facilities, especially the newer ones that are cropped up in the last 5 years. The government is seeing them primarily as teaching facilities and is not willing to spend many, many millions setting up their research capabilities. And there seems to be a large pool of highly capable, highly intelligent master's, PhD students. So it's how do you take advantage of all these plus points and leverage it. So setting up central facilities, I believe, would be one good way of doing it. You set up central facilities in key technological areas and you scatter them around the universities so that everybody has a bit of something. And they become the center of excellence for that particular technology that they wish to pursue. And they then, things then blossom out from there. So you've got to identify what it is that you want to do. I've been talking to you about 3-5 semiconductors, but there are many new exciting things out there at the moment. I mean, carbon nanotubes is one, things like metamaterials is another, organic semiconductors and polymers is another one. You can think of ferromagnetic materials. So all these things are new, are exciting. They need concentrated investment in one place to produce these, and then they can then be supplying other universities who want to research